So this is Quideo number 2, basic question. Part A asks to verify the linear model and state the equation of the linear model. So for the equation of the linear model, we're going to do y hat equals a plus bx. And in order to find that, we're going to come over here and do stat edit and enter all of our time data points that were given into list 1 and our pulse data that were given into list 2. And then we're going to stat calc, and we're going to go down to number 8, which is linear regression. And we're going to have list 1, which is our time, as our x value, and list 2 as our y value, which is the pulse. And we're going to calculate that. And that gives us our a and b values to use in the equation, which would be y hat equals 479.9341 plus a negative 9.6949 multiplied by x. And in order to verify that linear model, we are going to go into our stat plot and use the dot plot. And our x list is going to be list 1, and our y list is going to be list 2. And we're going to graph that. And as you can see, it follows a linear pattern and has a strong correlation based on the r value here of a negative 0.7459. And that verifies that it is in fact a linear model that is accurate to the data. Part B asks to predict the professor's pulse rate given 34.30 minutes. So we're just going to use the equation we found in part A, and we're going to do y hat equals 479.9341 plus a negative 9.6949 multiplied by that 34.30 minutes. And that's going to give us y hat equals 147.3990. And that prediction was very accurate according to his actual pulse rate of 152. Part C is asking if it gave us the pulse rate of 152 and we wanted to predict the swimming time, we would need to find another least squares regression line equation for this purpose. So in order to do this, we're going to come over to our calculator and we're going to do the same thing we did for the other one, except we're going to go down to number 8. We're going to switch list 1 and list 2. So list 2 is going to be our x value. List 1 is going to be our y value. We're going to calculate that. And that gives us our a and b values that we're going to use for our equation over here. So we have y hat equals 43.0973 minus plus a negative 0.0574 multiplied by x. So it's going to be y hat equals 43.0973 plus a negative 0.0574 multiplied by that 152 pulse rate that we were given. And that's going to give us y hat equals 34.3725 minutes. And according to the data given that it is 34.30 minutes, this prediction was very accurate, only 0.0725 off, so that's very accurate. Now for part D, it's asking to explain why 2 different regression lines were needed for part A and part C. So a least squares regression line looks at distances of the data points from the line only in the y direction. So you're needing to switch the x and y values in order to see the regression line for each of the different variables. So for part A, we wanted to see how the pulse was affected by the time. So the pulse was the y value and the time was the x value. And then for part C, we wanted to see it opposite, whereas the time would be the y value and the pulse would be the x value.